Guys, today we're going to look at average rate of change, and you've actually been calculating the average rate of change for functions since you first learned about lines. When you learned about lines, the average rate of change is constant. Oops, sorry, I'm using a new device. Let me see if I can make this happen. Is constant, and it has always been called slope to this point. Okay, so you know how to calculate slope, which means you know how to calculate average rate of change. We're just going to make it look a little bit fancier, but the basic process is going to be the same. When you're not looking at lines and you have other functions, the average rate of change varies, which means it's going to be different between different intervals. So we're going to need to calculate it over an interval. Specifically, we'll be giving those intervals to you. All right, so let's look at what that means. It means you're going to have to know a formula. And that looks kind of crazy. So you have the rate of change is equal to f of x2 minus f of x1 divided by x2 minus x1. But I promised that this was slope. And f of x is really just y. So this is y2 minus y1 over x2 minus x1, which really is slope, and that's what you've been finding. Right, so it's going to work just like that. Keep this in mind, you are going to need to plug those in. Noticing that the position here is important, just like it was when you were just finding slope, that the pieces that correspond have to go in the same order. So what does a constant rate of change mean? It means that if I take points, let's say here I have this point at 0, 1, and then I take a point, and let's look and see here. It looks like maybe I have a point at 3, 3. It means that when I look at that change, that rise over run, where I just went up 2 over 3, it means I'm going to be able to go up 2 and over 3 and hit another point, and up 2 and right 3. And that rate of change is going to be constant or the same everywhere that I check on that line. You're going to see the same thing happen over here. I know I go through the origin, and if I look, it looks like I go down 3, no, maybe right, so down 4, right 1, down 4, right 1. That's what it means to be constant. It's going to be the same everywhere. So what does varying rate of change look like? Well, it looks like this. I don't have that pretty little concept where I can go right 1, left, or sorry, right 1, up 2. So let's look here. So I have that same point that I had before at 0, 1, and now I have a point here at 1, 2. All right, so that means I go up 1, right 1. Well, can I do that again? Up 1, right 1? And no, I can't. That didn't work. So that's what it means. So let's see, where can I go? It looks like I can go up 2, right 1. So here I went up 1, right 1, but here I went up 2 over 1. So that rate of change was different as I moved on. And that's what it means to vary. When you look at the parabola on the right, my rate of change even goes from being negative, because I'm going down and right, so down 3, right 1, to, let's see here, I'm at 0, 1, or sorry, 0, 0, and I go right 1, up 1. So it's very different. On this side, it was negative 3 over 1, so it's 3, but over here, on the right side, it was 1 over 1. So again, my rate of change is different, or it varies.